On Friday, we messed with some Skittles to start looking at how the mole ratios, the comparisons of coefficients on one side of a reaction to another, can be used to predict how much reactant will make how much product. And we were making numerical connections from the reactants to the products. Using Skittles, it wasn't too much of a brain bender for most of you. But using real reactants, there's some more math to consider to figure out, well, if you have 3 moles of magnesium oxide, how much lithium oxide can that make on the other side of the reaction, depending on what the reaction is. This numerical comparison is called stoichiometry. It's a process that most students don't regard as real fun, but if you look at the cheat sheet I've just provided you, it's got grids to solve every single type of problem. Your big job today is to really focus on my procedure. If you can just hone in on the steps I take, even though there's a lot of them, you can practice and get good at this. But you really need to watch the order in which I fill these squares. For those of y'all that are working at home watching this video, we're working off a sheet of paper that you don't have. What I'm going to do is wave this up when it's time to work a problem. I suggest pausing the video and writing down the equation and the question so that you can get exactly the same experience as everybody else. So speaking of, take a look at number 1 on this sheet. My suggestion is in your spiral, write down that equation so that you can work with it the same way I'm about to. We'll be doing number 1. Again, this stoichiometry stuff is the idea that if you know how much reactant you have, you can figure out how much product you'll get. This is really important in lots of areas of the world, especially places like pharmacology, where people are trying to make drugs, and you don't want to waste any of that stuff, the expensive reactants, ingredients that you have. You want to be very efficient at making exactly what it is you need to make. So here's a reaction. All right, hydrobromic acid reacts with magnesium hydroxide to produce magnesium bromide and water. Right now it's not balanced. The balancing from last week is essential. However, I'm unable to go through the listing with you today because we'll run out of time and I won't teach you the stoichiometry. So you need to make sure that you're good at the balancing. But in the reaction that you just wrote, to balance it, a 2 will show up here and here. Now there's 1 magnesium on each side, 2 bromines on each side, 4 hydrogens on both sides. There's 2 there and 2 there, and then 2 oxygens on both sides. What's my mole ratio of this equation? 2 to 1 to 1 to 2. But we haven't actually started a problem yet. Look at the paper that's taped to your desk, and you'll see a question. It says, if 5.5 grams of magnesium hydroxide react, how many moles of water will form? It gives you a certain amount of a reactant and wants to know about a certain amount of a product. What I need to train you to be able to do is extract information. You need to pull out a given and an unknown, and it's real easy to do. The bottom of the paper taped to your desk tells you exactly how to find the given and unknown. What I want you to do is take your finger and put it on the given number, which is 5.5 grams. If you put your finger on 5.5 grams, or rather just 5.5, what comes immediately after the 5.5? I'm going to write down the entire expression actually. It says 5.5 grams of magnesium hydroxide. You should be writing this down in your spiral. You write everything that I write. All I've done so far is I picked out the number it gave me and the stuff that came right after it. And now I know my given info. Now, going back to the question, you'll also notice that there is a question phrase somewhere. Does everyone see the phrase, how many? If you look at the very bottom of the sheet, I give you a few different phrases that you might run into in regard to finding the question, like calculate or some others. But this one uses the phrase, how many? What comes right after the phrase, how many? Moles of water, right? This is the first step in all of your stoichiometry problems. They're all going to be word problems like this. Given number with his unit and compound, the question with his unit and compound. That's essential. Take a look at your new cheat sheet. It's got 4 different grids on it. You'll see that there are 3 grids on the front and 1 grid on the back. If you look at the way the grids are labeled, one says mole to mole, one says mole to gram, one says gram to mole, and the back says gram to gram. Look here. Here's how you pick your grid. What unit are we given? You see it? What unit are we looking for? Moles. There it is. This is a grams to moles problem. The problem gave us grams, and we want to turn it into moles of something different. And I've got a grid designed to do exactly that. You've just got to go and pick out the right one. Go to your new cheat sheet, find the grid labeled grams to moles, and let's draw him together. If you numbered the grams 1 through 4, which grid is the grams to moles? He's the 3rd one. Do this along with me. Kind of glance up here so you watch how I'm drawing it. If I copy that grid the exact way I see it on my cheat sheet, it starts off looking like that. And I also want to input the bold information. Here's what I mean by the bold information. It's the units. If I copy it perfectly, it looks like this. Make sure that you can verify that you know exactly where I'm getting all this from. I'm just copying straight off of the 3rd grid of the cheat sheet. Yes, sir. Yeah, it is. I'm so sorry. Isn't it fun being first period? Good catch. I'm sure everyone else was about to jump in and agree with you. We just got to fill in these squares piece by piece. It doesn't have to be difficult. The next thing I want is more letters. On the right-hand side of those, on your grid, you'll see repeated phrases such as given compound and unknown compound. We've already identified these things as our given and our unknown, so let's slowly fill them in. What I notice, if I look at the grid as a whole, is it says given compound, given compound, given compound, given compound. Do you see that? What's the given compound in this problem? MgOH2, all right? It's the compound associated with the given. So in all 4 of the squares on your grid that ask for the given compound, we've got to write this guy in there. All right, so MgOH2. 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 Because that's exactly what our selected grid asked for. But that square asks for something different. Look at your cheat sheet. What does that square ask for? The unknown compound. So let's go to the unknown section of our life. And the unknown compound is water. And yay, the only stuff we're missing from our squares at this point are the numbers, which the same grid that we're looking at on our cheat sheet tells you exactly what numbers goes in every one of these squares. So let's start right here. Look at your cheat sheet. Remember, we're on the grams to moles grid. What does it say goes there? The given number, 5.5. I'm just going to go straight across the top. Look at where I'm pointing. Look at your cheat sheet. What does it say goes there? A 1. All right. Straight over to this square. What does it say goes there? It says coef. C-O-E-F, right? That stands for the coefficient from the balanced reaction. In other words, it very simply wants you to go find water, which is why I've already had you write water in the square. My order is important. Go and find water and report his coefficient right there. What is water's coefficient up top? It's a 2. Let's go down to the bottom. This will be your most hated square. What does it say in this square? Periodic table. When you run into a periodic table square, we need the molar mass of whoever you already wrote in the square. We need to add up 1 mg plus 2 O's plus 2 H's. Let's do that together. We are finding the molar mass of magnesium hydroxide. Magnesium hydroxide is made up of 1 magnesium, 2 oxygens, and 2 H's, right? 1, and then that distributes in. This is review. We need to multiply these by the periodic table mass of these elements. Magnesium I have at 24.305. Oxygen 15.999. Hydrogen 1.008. We get our individual totals. Magnesium will stay the same. Oxygen will turn into 31.998. Hydrogen 2.016. And by adding up the parts, we can get the whole. Somebody give me that value. $58.319. Anybody argue that? The PT of MgOH2 is, say it again, 58.319. So that square is kind of a bummer. Some of the grids have 2 PT squares for 2 different compounds, which is why these problems can get long. But we've only got 1 square left. Look back at your cheat sheet. Look back at the grid. It tells you exactly what it is. What goes in that last square? It says coefficient. We need the coefficient of MgOH2. There's MgOH2. What's his coefficient? It's a 1. Multiply all the way across the top, multiply all the way across the bottom, and then divide the top by the bottom. You can work with me. I would go 5.5 times 1 times 2, and I get a top value of 11. That's just me multiplying across the top. I multiply across the bottom, 58.319 times 1. You'll get 58.319. Divide the top by the bottom. And I get to erase my question mark and fill him in with an answer. I get 0.19 moles of water. three other types of problems. This was grams to moles, but there's a moles to grams, a moles to moles, and a grams to grams. They all have their own grid, but as soon as you know how to read and do one grid, you can do any of them. You just got to make sure that you slowly copy the information from your cheat sheet into your work. Let's do another one. Take a look at number 2. Write down the equation. This says lead 2 bromide reacts with hydrochloric acid to produce hydrobromic acid and lead 2 chloride. What's the first step in solving a stoichiometry problem? Balance it. Very good. Don't forget to balance it. Make your lists, do your thing. I can see that to balance this, I need a 2 here and a 2 here. Now there's 2 of everything on each side, except leads. There's only 1 lead on each side. Go revisit the balancing video if you don't know how to balance. We need to identify a given number and an unknown number. So go to the new question that we have. It says, how many grams of lead 2 chloride are created from 125.4 grams of HCl? So I'm going to put my pretty little finger on the given number, which is 125.4. And I'm going to keep the stuff that comes right after it. Grams of HCl. From my experience, it's this step that most students miss out on, and then they're so confused on what goes where in their grid. Take your time. Pull out that given expression. Then take your finger and find the question. I see the question, how many? How many can be represented by a question mark? How many? And right after that it says grams of PbCl2. And now my grid is so easy to fill in because I've extracted the information in a meaningful way. This is a what to what problem. It's grams, given unit, to grams, unknown unit. Now you'll learn that grams to grams will be your least favorite, but the one I like to ask the most. If you can do a grams to grams, you can definitely do all the other grids because grams to grams is the longest. Flip to the back of your cheat sheet. That's where he actually is if you haven't already found him. But let's get the grid drawn slowly. All right, this is a big grid. There he is. Lots of info. Go ahead and put the bold information in there. Grams and moles, where they go. If you can copy, you can do it. Make sure I've done it right. What's the next thing we put in our squares? Compounds. Numbers are last. We need to put compounds after all these guys. Now, if you look closely at your grid, some of the squares want the given compound, hydrochloric acid. Some of them want the unknown compound, lead 2 chloride. Put them in the right place. Do it. 4 of them want given. And it looks like it's these 4. Stop me if you don't like something I'm doing. My cheat sheet says that 3 of them want the unknown compound. The unknown compound is PbCl2. And now we can input our numbers. Look at your cheat sheet. My very first square in this long, long grid says the given number. So that's 125.4. Going to go straight across the top. Compare to your cheat sheet. What number goes there? Shout it. 1. That was a terrible shout. Happy Monday morning to you. To this one, what goes there? Not a 1. Look closely. It says coefficient. Don't get lazy already. It wants the coefficient of PbCl2. PbCl2 is here. His coefficient is a 1. So you were kind of right. Uh-oh, this last square is a bummer. What does he want? The periodic table. We need the PT mass of 1 lead and 2 chlorines. PbCl2 is made up of Pb and Cl. 1 of those guys. 2 of those guys. Lead has a PT mass of 207.2. Chlorine, 35.453. We've got our individual totals, add them up, we'll get the total mass of PbCl2. Who's got that number for me? Does that sound right? Try again. I think it should be bigger than that. It's just a decimal button slip. That's fine. 278 point what? I'm sorry. 1 lead, 2 chlorines added together. Down to the bottom, let's get some more numbers. Again, we're to a periodic table square. We need the PT of an H and a Cl. At least that one's easy. 1H is 1.008. 1Cl is 35.453. Add them together and you'll get 36.461. 1H and 1Cl based off periodic table masses. This square wants a coefficient. The coefficient of HCl is a 2. This square is a 1. Pause real quick. Look here. Just so I can explain what the heck this is doing. This is called dimensional analysis. In dimensional analysis, two things are true. Every stack of information is equal to each other. And every diagonal information has units that match. What this allows us to do is do a direct comparison of things while also canceling out units and being left with a desired ending unit. For example, 1 mole of HCl has a mass of 36 grams. All right? These two are equal to each other because in my mole ratio, I know that 1 to 2 to 2 to 1 is all on the equal playing field. So they directly compare to one another. And here, 1 mole of PbCl2 has a mass of 278 grams. Every stack of information is actually equal to each other. But when you look at what the units do, grams will cancel out, moles then cancel out, moles then cancel out, and I'm left with just grams of PbCl2. So it's a magical little math trick that you don't really have to understand if you don't want to, but some of you like to know the reasoning. We need to multiply across the top, multiply across the bottom, divide the top by the bottom. So let's do so. Across the top, 125.4 times 1 times 1 times 278.106 is going to give you a great big number. Now, there's one of two things you can do at this point. For teaching's sake, I'll write that big number. All right, it's 34,874.4924. And that's fine. We know that's the top number that needs to be divided by the product of the bottom. But for those of y'all that are handier with a calculator, while I have that number on my screen, I could just click divided by. It'll save the answer, but the trick is you want to put the bottom in parentheses if you're going to do it like that. If I put the bottom in parentheses, this 36 times 2 times 1, close parentheses, and hit enter, it'll just do it for me. But you can go through the steps of writing it. For teaching's sake, I'll do that. Across the bottom, 36.461 times 2 times 1. I get a bottom number of 72.922. And we are so close to an answer now. 34,874.4924 divided by 72.922. No more question mark. We know the answer. What is it? Or 78.24. Perfect. And understand the importance here, guys. If a physician needed 478 grams of lead-2 chloride for something, we know right away that we have to have at least 125.4 grams of that if we're doing it in this reactional way. But the numbers are absolutely correct. I meant to do something on the previous problem, my fault. The answer here is called a theoretical yield. Write that down somewhere. The answer to any grid is called the theoretical yield. That's actually, if you don't know how to spell it, it's on your cheat sheet. Actually, verbatim what I just said is there. But at the top wordy section of your cheat sheet, it says the answer to any problem is called a theoretical yield. So our theoretical yield on the last problem was that decimal answer that we got. What do you think of stoichiometry so far? Awesome opinions. I'm glad you shared them with me. We only have time to do one more problem, even though there's two there. I want to work it out with you in stages. You don't have to. If you right now feel like you can do this, then do it. Do number 3. If you'd like a little bit of help, but some independence, then you can stick with me. Up to you. But number 3 will be our last one. So let's take a look. I'm going to write down the equation. When balanced, it's got a mole ratio of 1 to 2 to 1 to 2. First, I'll give you a moment. Pull out your given and unknown info in the way that I do that. See if you can properly pull out the given and unknown. You do it too at home. I can put my finger rather, on the number 6.8, which means the info that comes immediately after that is my given. Moles of CF4. I see the phrase what will, meaning that must be, it wants to know what will be moles of F2 if you read it properly. While our last problem will be your least favorite, grams to grams, this should be your most, moles to moles. And if you look at the length of the grid, you'll see why. This is a moles to moles problem. If you're still working with me, draw the grid and add the bold info. You'll notice that the bold information is all moles. Now go and add the formulas that it wants, the compounds, given compound versus unknown compound. It appears these two squares want the given compound, CF4. And this one square wants the unknown compound of fluorine. Go and add the numbers. The given number is 6.8. Both of these squares say coefficient if you look at the cheat sheet. So as long as you balance it correctly, and I hope it's becoming clear to you why you're in a lot of trouble on stoichiometry if you don't know how to balance. All of the grids need coefficients. They have to be the right ones. The coefficient of F2 is a 2. The coefficient of CF4 is a 1. Multiply across the top. In this case, you don't have to multiply across the bottom. There's only one number down there. You can just divide by him. What do you get? I get 13.6 moles of fluorine.